Assalamu alaikum. In this video, I am discussing grade 12 2024 batch second term examination of 2023. The first question we have to find the which of the following quantities is equivalent to pressure. We know the Bernoulli equation P plus half rho V squared is equal to constant. From that we can say it has to be the first answer. The second, what is the group of different dimension if seen as a plus bx plus cy is equal to d. Uh, first answer, a comma b. A and b have similar dimension. Cy d. Cy and d have similar dimension. Ax cy. Now we have a plus b. A plus b. The dimension of a plus b will be the dimension of a. So we have the dimension of ax and dimension of cy identical. The fourth answer, bxd. Again, we can write the dimension of a plus b as the dimension of b. So bx is identical to cy and is also identical to d. So it's not the fourth answer. Fifth has to be the answer. Third, a triple beam balance is given. We have to find the reading. Now, let's look at the maximum reading of each beam. The first beam reads a maximum of 100 grams. The current reading is 60 gram. Here it can read 500 gram and it's reading 200 gram. And the third beam, it can read maximum of 10 gram. And if you look between two 1 gram calibration, we have further divisions. That means the least count is going to be 0.1. So it's reading 3.5. It's reading 3.5. Let's add all of them together. We get 263.5. That's the fourth answer. The fourth question, consider the following statement about traveling waves. All the particles in it have the same phase. So consider a traveling wave. Let's take two example points A and B, and both of them are in antiphase. Let's say the waves or the SHM are as shown, they are in antiphase. So all the particles in it have the same phase is incorrect. Statement B, all the particle in it undergoes a simple harmonic motion. Yeah, it's true. Statement C, all the particles in it have the same energy. So here we have a progressive wave which is traveling forward. If that statement was for an SHM, it will be true. SHM will execute SHM in the same place. When the displacement is zero, we have maximum kinetic energy. When the displacement is maximum, we have maximum potential energy. Anywhere in between, we have a combination of them, combination of potential plus kinetic, which is equal to the total energy. So the total energy is equal to kinetic energy maximum and potential energy maximum. So this is for an SHM. So you might think a wave, it is a series of SHM, right? Particles executing the same SHM. But the problem with a progressive wave is we cannot make sure the medium throughout is going to be identical or similar. So if the medium changes, when I say medium, Just think about a string. Will the string be identical throughout? No, we cannot make sure. And if we think about the motion of sound waves, the pressure might change, right? The pressure might change at various positions. So, statement C is incorrect. Then the answer has to be only B, second. Speed of sound in air. A is the proportional to absolute temperature. First, let's write down the equation. First, let's write down the equation for speed of sound in air, which is V is equal gamma RT over M. And they say velocity is proportional to absolute temperature, but velocity is proportional to the root of absolute temperature. Statement B is the inverse proportional to the molecular mass of air. V is proportional to 1 over root of m. Again, it is not inversely proportional to m but inversely proportional to root of m. Therefore, B is also incorrect. C is proportional to the root of ratio of principal molar heat capacity of air. We know that gamma is equal Cp over Cv. Cp over Cv is the ratio of principal molar heat capacities of air. Now, velocity is proportional to root of gamma. So, proportional to the root of ratio. Hence, it's correct. The answer has to be third, C only. Question number 6. An object is in equilibrium under influence of three forces, always acting in the same plane. So all these three forces are in the same plane. When we have equilibrium, first, in case of equilibrium, what are the conditions to be in equilibrium? There are only two conditions to be in equilibrium. For equilibrium, the first condition is resultant force has to be zero. Second condition is moments has to be zero. And when we have different number of forces, these two conditions they also satisfy some other cases or some other yeah special situations. Now let's look about three forces. When we have three forces, these three forces can be parallel or they can be non-parallel. Whether they are parallel or non-parallel, these two conditions has to be satisfied. So statement A, the algebraic sum of moment about any point in the same plane is zero. So it's true because it's a basic condition. So statement A is correct. B, line of action of three forces meet at a point. That is only true for non-parallel forces. All three forces, their lines of action has to meet at a single point. But in case of parallel, now the line of force of these forces never meet each other. But let's say we have F1, F2 and F3. If the statement was like the resultant of F1 and F2, the line of action of resultant of F1 and F2 uh, meets the line of action of F3, then it is correct because the resultant of F1 and F2 is equal to F3 and is along the line of action of F3. Otherwise, if it is not in the line of action of F3, if there is a separation between them, this will become a couple of force where moment is not zero. If moment is not zero, it doesn't satisfy the condition of equilibrium. So statement B, line of action of three forces meet at a point is incorrect. The resultant force is zero, that's correct. The resultant of any two forces is equal to the magnitude of the third force. So it is also true, right? F1 and F2 has to be equal to F3 and it will come along the line of action. Here also, if we have F1, F2 and F3, the resultant of any two force has to be equal to the third and it should be opposite. So, statement B, the resultant of any two forces is equal to the magnitude of third force. Statement D is correct. Therefore, answers is A, C, D, fourth. Here, you have to be careful if they didn't mention magnitude. If it is just mentioned like the resultant of any two forces is equal to the third force, then the statement is incorrect. When we say two forces are equal, we are also talking about the direction. As it is mentioned magnitude, it's correct. Or they have to mention equal and opposite to the third force, then it is correct. Hope you got the difference between the statements. Question number 7. The fundamental frequency of a closed tube is 220 Hz. Frequency of the first overtone when the tube is 1/4 full of water. Okay, let's first draw a diagram for these two situations. So we have a tube. The fundamental frequency of closed tube. So this is the fundamental frequency. This will be the standing wave pattern for fundamental frequency. They say this frequency is 220 Hz. Frequency of first overtone when this is filled with water for 1/4. So same tube filled with water for 1/4. So let's say this is L by 4 where this is L and it's the first overtone. That means we are going to have a standing pattern like this. So here V is equal to F lambda. V is constant in both the cases. That's the speed of sound in air. Air doesn't change. So F is constant. Then F1 lambda. Here we have lambda by 4. So lambda is equal to 4L, which is equal. Here let's say this is F2 into the length is 3 by 4. The remaining length is 3L by 4, and which is equal to uh, 3 by 2 lambda, or 3 by 4L is equal to 3 times lambda dash by 2. So lambda dash is equal L by 2. So this is L by 2. Now let's simplify. L and L cancels. F2 is 8 times of F1. F1 is given as 220. Therefore, 8 into 220. Any mistake? Oh, sorry. Here we have 3 times of lambda 4, not lambda 2. So here lambda is equal to L. So lambda is equal to L. That means F2 is 4 times of F1. So that is equal 880 hertz. The fifth answer. Question number 8. A wheel rolls without slipping along the horizontal surface with speed of v. The difference between the resultant velocities of point A and B located diametrically with respect to ground. So we have to find the velocity with respect to ground. So this wheel is rolling without slipping. The linear velocity is v, and at these edges we are going to have two type of velocity. One is the tangential velocity, and the other is the linear velocity. So let's consider the points A and B. The linear velocity is v. Here also the linear velocity is v. And there is a special case when a wheel rolls without slipping. The linear velocity is equal to the tangential velocity, but the directions are different. I am talking about the magnitude. So as the wheel is rolling forward, here we are going to have a tangential velocity in this direction. Magnitude is v, and here we will have v. Magnitude is v, but it is going to be perpendicular. And now if we get the difference, resultant velocity of points A and B, so the difference between, so we have to get the difference between them. We get the difference, let's say VA minus VB. If I deduct B from A, the velocities in same direction will get deducted. Now these two velocities are in the opposite direction, therefore V minus V up. So we get 2V in the downward direction. The answer has to be fourth. So I have explained in a video how tangential velocity is equal to linear velocity. I will give the link in the description. Question number 9. The graph shows the variation of wavelength lambda with frequency f of a sound wave when the air temperature remains unchanged. V is equal f lambda. If we check the speed of sound in air, the equation for V is gamma RT over M. So in air, R, gamma, M, all of them are constant. If temperature is constant, then the velocity is constant. Temperature remains unchanged. Hence, this is constant. Then F and lambda, they have inverse relationship. The answer has to be third. Question number 10. A student holds a thin paper strip of mass m below his lower lower lip and keeps the strip horizontal by blowing an air of density rho on it with velocity v. If the surface area is a, the minimum velocity blowing, so at what velocity he has to blow just to balance. So beneath we will have atmospheric pressure, and when he blows with velocity v. So we have to apply the Bernoulli equation in a streamline. I'll consider a point A here and a point somewhere at a very large distance in this same streamline. There the velocity will be almost zero, because we know when we blow the air diverges, so the velocity will keep on decreasing. So I'll apply the Bernoulli equation between these 2 points. PA plus half rho V squared plus uh, H rho G we can omit because we are going to consider at the same level, that is equal at infinity or at a greater distance. It turns out to be the atmospheric pressure plus zero velocity. So now we have a relationship for P minus PA, that is equal half rho V squared. And luckily, under this also we have atmospheric pressure. Now, using this, I can find the force that is going to get exerted upward because the pressure on bottom is high. To find it out, we have to multiply by the area. So, area into pressure difference gives you the force, and it has to be equal to mg to balance it. Hence, V squared is equal to mg over a rho. So V is the square root 2 mg over a rho. That's the first answer. Question number 11. If a particle performs simple harmonic motion, has amplitude a and frequency b over 2 pi, what is the acceleration of the particle at endpoint of an amplitude? We know the equation for acceleration. A is equal minus omega squared x. Let's find out omega. Omega is 2 pi f. So 2 pi into b over 2 pi. We get omega is equal to b. And x for amplitude, it is going to be a. So the acceleration is equal minus b squared a. They need only the magnitude. Therefore, that's the fourth answer. Question number 12. We have a block that is being pushed along the surface upwards. So first, let's say the applied force P is equal to 0. When P is equal to 0, we have a downward force mg sine theta. So this is theta. To balance this, to balance this box, we will have a friction upward. This friction, it is static, most of this time static friction. Sometimes it could be at the limiting case also, but usually it's static. Now when I start to apply force in the upward direction, the static force starts to decrease, because static is a self-adjusting force. It will be equal to, no, it adjusts itself so as to provide the required friction. For example, let's say we apply 15 Newton of force. No, we are applying 10 Newton of force. The limiting friction between these two surfaces is 15 Newton. So remember, that's the limiting. The idea of limiting is the maximum friction that is available between these two surfaces. But here we only apply 10 Newton. Therefore, 10 Newton force is sufficient to balance this 10. Now I'll increase this to 12. Remember, this can supply, or this can apply a friction of 15 Newton maximum. Now I only provide 12 Newton. Friction will self-adjust itself to 12 Newton. And similarly, until 15, it is going to adjust itself. So here also we have the same idea. When we apply a force, the static friction will adjust itself. Obviously, it's going to reduce. And after some time, it will keep on reducing. And at an instant, this one will become 0. So it becomes 0. During that, the applied force will equal this mg sine theta. And when I increase the force beyond that, now the box has a tendency to move up. Hence, the frictional force will be in the opposite direction. So initially it started pointing up, but now as force applied increases, it's down. So they are in the opposite directions. Obviously, the answer has to be first or second. It's not the fourth, because when there is no force applied, they say friction is 0, which is not the case. Now, first and second, we know when we reach limiting, when you apply a force beyond limiting, it starts to move, and suddenly the friction will drop and it becomes the dynamic friction. But here there's a smooth region, right? There's a smooth graph where even after limiting, it's not dropping quickly. So the answer has to be first, not the second. Question number 13. The figure shows a wire of uniform cross-sectional area. What is the angle the wire AB makes with vertical when it is suspended from A? We know when we suspend an object, its center of gravity will be along that same vertical line. Let's try to find out the center of gravity. AB is uniform, therefore the center of gravity will be at the center. Let's consider it to be M. So this is M, and this is 2 times of L, therefore the center of gravity will be 2M, and at the center, and here this point also will be M. Remember, when we hung about a point, all the center of gravity, now we have found them separately, right? All of them should align in the same line. Or let's try to find out the center of gravity of this system. To that, I'll connect all these points together. M and 2M, sorry, M and M, M and M are at same distance, so their center of gravities will be at the center. Now this becomes 4mg. So we have found the center of gravity of this object will be at the center, and it is 4mg. So if we hung about A, remember, about where we have hung, in that line only the center of gravity will lie. Now let's say we hung about A. So along this line only the center of gravity has to lie. If this diagram is not clear, I will draw the proper way. If it is tilt, I have drawn. If it is tilt, without redrawing, you can do the question this way. To the point where it is hung, you will draw a perpendicular line and try to find the angle. Or if we draw it properly, this is the point. So this is A, and the 4mg should lie here. Now we have to find what AB makes with vertical. So we have to find this angle AB with vertical. This side is L. Total length is 2L, therefore center is L. This angle is 45 degree. But we don't have an answer 45 degree, but which is identical to tan inverse 1. Question number 14. Two objects P and Q move along a straight line. That displacement versus time graph are shown in the figure. Consider the following statements. The velocities of the two objects are in opposite direction. So this is an ST graph. The gradient of the ST graph will give us the velocity. So here this has a positive gradient. This also has a positive gradient, which means the velocities are positive. So both of them are in the same direction. Statement A is incorrect. The velocity of both objects increase with time. It's incorrect. The gradient here is increasing. Gradient of P is decreasing. So Q velocity increase, P velocity decrease. P is decelerating, while Q is accelerating. Correct. Initial velocity of both of them are equal. No. The gradient of Q is less. The gradient of P is high. That means velocity of P greater than velocity of Q. Wrong. The answer only C is correct. Third answer. Question number 15. A bow of ship steaming at 5 meters per second into the ocean rolls traveling in opposite direction rise and falls with period of 10 seconds. It is noted, so we have a wave and this wave is traveling in a direction and the ship is traveling opposite to it with velocity 5 meter per second. It said the crest of the wave is under the bow, so at the rear. So this is the crest, and adjacent trough is under stern. So adjacent trough, it is under the stern in front of the ship. The length of the ship is 60 meters. What is the speed of ocean wave relative to sea? Let's say this is the velocity v. So they say the ship rise and fall with a period of 10 seconds. What do we mean by a period, time period? If we start at the crest, the time taken to come to the crest again, that time is 10 seconds. They have given information about crest and trough. So to travel from crest to trough, it will take 5 seconds. And now we have to find the velocity v, right? To do this, let's get the idea of relative velocity. So I'll stop the wave and let the boat move. So introduce v. So the speed of boat is v plus 5. So the wave is not moving. The boat has to move from trough to, sorry, crest to trough. The distance is 60 meters and it takes 5 seconds. Remember, when we are dealing with relative velocity, the time doesn't differ, time is independent. Time independent of frame of reference. Okay, so if we deal with these waves moving, also the time will be same. If we deal by keeping one object at rest, then also the time will be same. So 60 meters in 5 seconds, it is 12 meter per second. The boat has 5 meter per second velocity, so velocity of wave has to be 7 meter per second. That's the second answer. Question number 16. A uniform cross-sectional area, a tube of uniform cross-sectional area is partially filled with water. Its length is L. An oil having density 2 by 3 of water is placed inside a U-tube of one arm for length equal to the length of water column. What is the difference between the liquid level in the two arms at equilibrium? Okay, we have a U-tube. So here, when we have water and oil, there will be difference in the levels. There will be more oil above the common interface than water. So this is the common interface. uh, let's say this height is x. This will be L. So let's get a relationship between L and x. uh, Both the pressures are equal, so x rho wg is equal L 3 by 2, no, 2 by 3 rho wg. So x is equal to 2L by 3. And now we have to find this height, difference in level, right? So we have to find this separation. Totally it's L, as this is x is 2L by 3, the remaining has to be L by 3. So that's the fifth answer. Question number 17. Question number 17. A wire of length 1.5 meter is clamped at both ends under tension. It is plugged to produce an antinode at its center. So remember, we are only plugging at the center. So the possible waves, when we plug at the center, we will get an antinode at the center. So the first possible is the fundamental, and the next possible, it's not this, because to get a wave like this we have to hold the center and plug on these 2 points. Okay, then only we will get a wave like this. So the second possible is this, and the third possible one is going to have 5 loops. So here the total length is 1.5. We have to find the wavelength, 3 highest wavelength in meter. So here we have lambda by 2. Lambda by 2 is equal to 1.5. So lambda 1 is equal to 3 meter. Here we have uh, this is lambda by 2, right? So we have 3 times of lambda by 2, which is equal to 1.5. So lambda 2 is equal to 1 meter, and here we have 5 times of lambda 2, which is equal to 3 by 2, 0.6. So that's the third answer. 3, 1, 0.6. Question number 18. Question 18. Two particles are free to fall from a point at an interval of 2 seconds. How long after the first particle is dropped will the two particles be 40 meter apart? Okay, when we drop a particle in the first second, it is going to travel 5 meters. In the second, it is going to travel uh, 15. We know, right? 1 is to 3 is to 5 is to 7. So in the third second, that this gap is 5. this gap is 15, this gap, uh, 5 times of 5, that's 25. Now let's say we drop the first particle. It has traveled for 3 seconds. Then the total distance it traveled is uh, 40, 45. And the second particle, if we drop 2 seconds later, now it has already traveled 5 meters. So the first particle is 45 meters below where we dropped, and the second particle is 5 meters below where we dropped. So the separation between them is going to be 40 meters. Then how long after the first particle is dropped will the two particles be 40 meter apart? Two particles are free to fall from a point at an interval of 2 seconds. How long after the first particle is dropped will the two particles be 40 meter apart? Therefore, the answer is 3 seconds. Third, question number 19. The time difference between the P wave and the S wave of an earthquake originating at point R inside the Earth to point Q on the Earth's surface is 20 minutes. If the speeds of P and S are 800 and 600, respectively, the length of QR. Remember, the distance between QR is same. One of the wave is going to travel at 800 km per hour. The other wave travels at 600 km per hour. The distance traveled is same, but the time taken is going to differ. Now let's say this took time t1 and this took time t2. T2 is going to be greater than T1. We know that V is equal to D over T, so T is equal D over V. So T1 is equal X over 800, T2 is equal X over 600. We have to get the difference T2 minus T1, that is X common, 1 over 600 minus 1 over 800. So when we simplify, we get we can multiply this by 4 and this by 3. Therefore, we get uh, 1 over 2400. That is the time. And it is said 20 minutes, but we are dealing with hours. If we convert 20 minutes, that one third of an hour, x is equal to 600 kilometers. It has to be the first answer. Question number 20. A particle moves from point A along a smooth vertical surface and just passes through point D. What is the distance from B to strike horizontal surface after passing point D? Now here, uh, when this particle is moving along AB, it is a normal linear motion, but from B to D, it's a vertical circular motion. When it comes to vertical circular motion, if you want to find the speed, we use the conservation of energy. And now they say the particle just passes point D. If the particle just passes point D, that means this particle is in a circular motion until D. So we should have we should have centripetal force. The centripetal force over here, I'll redraw the diagram. So this is the circular path, and over here, to be in the circular motion, we should have a centripetal force. The centripetal force is given by R and mg. Mg will give centripetal force, and the reaction force also provides the centripetal force. But they say it just passes point D. So as they have mentioned, it just passes point D, then reaction is zero. It is just touching this point. So R is equal to zero. It has left the surface. It doesn't have any contact with the surface over here. So if R is 0, then mg is equal mv squared over R. There is a velocity v. So we can find v. V is equal square root of gr. So this will move in a projectile motion. During that, it has to fall down a distance of 2r. We know in a projectile, the vertical motion is responsible for the time. So let's find out the time taken to fall that distance. S is equal ut plus half at squared. So S is 2r. Initial velocity in the vertical direction is 0. So we get half falling under gravity. Therefore G t squared. So when we calculate, we get T is equal uh, 4 4r over G square root. So that's the time. Now let's find out what's the horizontal distance. I'll take it as y. Y is equal v into t. So v into t is equal gr square root into 4r over g. So simplifying, we get root of g cancel, 4r square root. So that is 2r. We get the second answer. Now you might have a doubt that isn't the velocity, as they have mentioned, just passing point D, isn't the velocity over here 0? Okay, let's think about that for a while. Now we have a circular motion just like that. Sorry. We have a circular motion, and if the velocity over here is 0, if the velocity over here is 0, that means it is not in circular motion. It cannot be in a circular motion because we need a centripetal force. For that centripetal force, we need a tangential velocity. So if you are arguing that over here the velocity is 0, but just before there could be a velocity, that is also not possible, because if there is a velocity over here, obviously the velocity all of a sudden cannot go to 0. Then what might happen? How can the velocity be 0 over here? Can we have a situation like this? Let's think about that for a while. Now, to go in a circular motion, we need a centripetal force. So that centripetal force is given by R and mg. At the maximum. Okay. So, velocity, if the velocity is 0, then R is 0, and this entire force has to become 0. That means there is no centripetal force. So there's a contradiction, right? We have a centripetal force but no velocity. There's a contradiction. So this is the thing should have happened. The particle should have gone up and it should have left the surface somewhere over here where the reaction becomes zero. When the reaction is zero, now we can have a velocity zero over here. Okay, that means if the velocity over here is zero, the particle can never uh, go in a path like this. Instead, it should have left the surface. It should have left the surface somewhere before, and from here on, it is no more in a circular motion. It is just in a motion under gravity. Okay, so uh, if we get a question like the velocity at maximum is zero, that means the particle has already left the circular motion somewhere before. To find that point, you have to find where r is equal to 0. So here you can equate, right? You can equate the centripetal force. Here mg, let's say this angle is theta, then mg cos theta plus r is equal mv squared over r. So we must make we must make r 0, because when it leaves the circular motion, it is not in contact with the surface. So you have to make r 0, and then we get mg cos theta is equal mv squared over r, cancels, then cos theta is equal v squared over gr. So if we know these values, we can find at which point it leaves the circular motion. Okay, so here the idea is, you might have a confusion that when they say it has to just reach point D, you might think the velocity has to be 0. But if the velocity is being 0, that means the particle has already left the circular motion somewhere before, not at point D. Okay, so if it has to just pass this point, it has to leave the circular motion at maximum. When it leaves the circular motion, r becomes 0. That is what I have done here. Hope you got the idea. Next, let's look at question number 21. A vibrating air in one enclosed tube at temperature 51 gave 3 beats with vibrating tuning fork. The temperature was raised to 127 degree and still gave 3 beats. What's the frequency of the tuning fork? Now let's say the frequency of the tuning fork was F, and when we had temperature 51 degrees Celsius, we have 3 beats. That means the frequency of that tube should have been 3 beats or 3 hertz less than the frequency of tuning fork, and when we increase the temperature, it should be 3 hertz greater than the tuning fork. Then only it's possible to have 3 beats in both the cases. Now let's look what's the relationship between frequency and temperature. Here we have a one enclosed tube. As this is a one enclosed tube, the length is restricted, and length is equal to lambda by 4. When length is restricted, lambda is also restricted. So the velocity of sound in air is gamma RT over m square root. So we have V proportional to square root of T. but V could be written as F lambda proportional to root of T. Lambda is constant, so frequency is proportional to the root of T. Now, in the first case, F plus 3 is proportional. This was at 127C, right? Which is 400 kelvins, and this is at 51 degrees C, which is 324 Kelvin. So F plus 3 is proportional to root of 400, and F minus 3 is proportional to the root of 324. Let's divide them. By dividing F plus 3 over F minus 3, we have divide by 4. So 400 divided by 4 is 100. 324 divided by 4 is 81, and get the square root. So that's 10 by 9. F plus 3 over F minus 3 is 10 over 9. So 9F plus 9 into 3 is equal 10F minus 3 into 10. So simplifying, we have F 3 into 19, which is equal 30, 27, 57 hertz. So that's the second answer. Next, let's look at question number 22. Two identical wedges of mass m by 2 are placed on rough horizontal surface, and block of mass m is placed on them as shown. So this is mass m, and these are m by 2. If the system is in limiting equilibrium, frictional coefficient between wedge and ground. Let's mark the force. We will have a reaction by the wedge and by the mass. And on this wedge tends to move out, therefore limiting friction is towards the right. We have its own weight m by 2. Similarly, the system will be identical. Now consider this box only. Considering this box, this is R and mg. Equilibrium under three forces. This angle is 45. Using the geometry, we can get, so 2r cos 45 is equal mg. So r is equal mg over 2 cos 45. Let's have this equation. Now consider this wedge. We have a reaction, and mg by 2, the normal reaction of this surface, I'll consider as r dash. So r dash equal mg by 2 plus this angle is 45. So r cos 45. So um, r dash is equal mg by 2 plus, instead of r cos 45, we can consider it as mg by 2. So r dash is equal mg. Now F equal mu r. They say limiting equilibrium. So the force towards the horizontal force by this box is again r cos 45. So r cos 45 equal mu, this is r dash, which is equal to mg. So r cos 45. that is again mg by 2. Mg by 2 is equal to mu mg. So mu is equal half or zero point 0.5. That's the first answer. Question number 23. A mass of 500 gram is placed on cubic wooden block which sinks and floats only in water. To remove that mass, the block rises 5 centimeter. Water density is given. What is the length of side of block? Okay, so let's say we have a block whose side length is x. So if we put this in water, it completely submerged. So when we place 500 gram or zero point 0.5 kilogram, which is 5 Newton. If I place 5 Newton, it will sink and float. If we remove this 5 Newton, block comes 5 centimeter above. Okay, 5 centimeter above. So what is this length? It's x minus 5. Now we have to find the length of a side, right? Here, this volume, when we remove the mass, there's a volume submerged. That will balance the weight of the block. I mean weight of the wooden block. And this portion, it is used, or when we place this block above, this submerge to balance this weight. So 5 Newton is equal to the upthrust due to this part. Okay, uh, we know V rho G. V is 5 into x square centimeter. Therefore, I'll convert it into meter. 10 to the minus 6. Rho is 1000. G is 10. So 10 to the power 4. Simplifying, 1 is equal x squared into 10 to the minus 2. So x squared is equal 1 over 100. X is equal 1 over 10 meter in centimeter. That's 10 centimeter. Third answer. Let's try question number 25 and then look question number 24. Remember here, uh, this wheel will rotate above this point and there will be a reaction from the step at this point, and the other forces are weight mg. Here we have to find what is F, minimum force or minimum value of F. We are not needed to find R. So I'll get the moment about this point. And when I apply the minimum force, there is no contact between ground and this wheel. Therefore, reaction here also becomes 0. Reaction over here. the reaction over here also becomes 0. So let's find the moment above this point. For that, we need the distance. This distance will be r. This is going to be h. So this distance is h minus r. No, r minus h. Using that, I'll be able to find this separation, which is equal to r squared minus square of this. So this is equal to r square minus r squared minus r minus h square, the Pythagoras law, square root into mg. That will give the moment in this direction. Okay, so just by taking this itself, I'll say the answer is second. Anyhow, let's try to find this separation, the separation over here. The total height will be 2r. Total height is 2r. Deduct this part minus h. It will give us this height. Okay, and this height is h. So I'll deduct h from this. It will give me this height. So I can write y is equal, let's say this is y, let's say this is y. So 2r minus h plus h. So we get this part also. So this is equal f into 2r minus h plus h. So we can simplify for f. So that's the second answer. Do we have any other way we can do this question easily? Just by looking at the answer, we can tell the answer has to be second. The reason is, if the height h or simple h changes, with the h or simple h change, obviously f is going to change. So uh, f is varying only in this answer when h and simple h change. Question number 24. And next, let's look at question number 24. At one end, a piece of iron is suspended in a light steel wire. When transverse vibration was applied, wire vibrates with frequency F1. When the piece of iron is completely immersed in water, the wire vibrates with frequency F2. The number of loops does not change. Okay, now we have a string. It is hung. It will have a certain tension in this string, and they say the number of loops doesn't change. If the number of loop doesn't change, for example, if we have one loop here, then lambda won't change. Lambda is constant between the first and the second case. Okay, if this also has only one loop, then lambda is constant between the first and the second situation. But the frequency changes, right? This is f1 and this is f2. Now let's look at the equation for velocity. V is equal root T over M. Same still via M is same. Instead of V, we can write F lambda. We can write F lambda, but lambda is constant. So frequency proportional to root of T. Then F1 is proportional. So tension is equal to the weight mg. So it is proportional to mg. And here we have tension, upthrust and mg. So tension is equal mg minus u. So F2 is proportional mg minus u. Let's divide. I'll take F2 over F1. This is equal mg minus u over mg, which is equal 1 minus u over mg. Let's try to find out the upthrust. The upthrust, we know upthrust is equal V rho W G, and this is the complete volume of this object because it is completely submerged. We can get an equation for mg in terms of volume. V rho. So we can replace volume with uh, sorry, not mg, m is equal v rho. So just divide u over m. U over m is equal, or I'll take mg, so we get v rho g. V and v cancel, we get rho over rho w. Sorry, rho w over rho. So f1 f2 over f1 equal 1 minus rho w over rho. So they are asking for the relative density, right? Rho over rho w is s. F2 over f1, 1 minus 1 over s. Let's subject s. 1 minus s is equal 1 minus f2 f1. So 1 over s is equal f1 minus f2 over f1. S is equal f1 over f1 minus f2. Oh, sorry. Here it's square root, right? Proportional to square root. So this should be squared. I mean, f squared is proportional to t. So everything gets squared. Then the final answer also gets squared. S is equal f1 square over f1 square minus f2 square. First answer. Hope you are clear. If you all have any doubts related to this question, feel free to ask. I have added the contact information in the description. Assalamu alaikum.